Hi everyone, my name is Makumba Gerard. I would like to welcome you in our second part looking at motion under gravity. And if you are new at EduMath, consider subscribing and hitting that notification bell such that you can be notified when we put the third part. For now, let's get started with some guiding questions. Alright, a particle is projected upwards with a velocity of 34.3 meters per second. So let's project the particle first. So we have this particle projected at the initial velocity of 34.3 meters per second. Okay. Find how long after projection the particle is at a height of 49 meters above the point of projection for the first time, that's in part A, and the second time. So there is a height here. This height is of 49 meters, okay, above the ground. They need us to find how long after projection the particle is at a height of 49 meters above the point of projection for the first time. So when this particle is projected upwards, when it reaches this point here, this is going to be the first time it reaches the height of 49 meters. So it continues with its journey upwards until it reaches the maximum height, where the velocity there is 0 meters per second. Then it starts moving down. Now on its way down, it is going to encounter a height of 49 meters again for the second time. Alright, so we are interested in the time here and in the time here. Alright, now we can go ahead to summarize the information that is in the question. We have that the initial velocity, this is 34.3 meters per second. We have the acceleration, this is going to be negative g because we are moving up. Then we have the displacement. So the displacement of our interest is 49 meters, right? We are interested in finding the time. So we are now going to use the displacement is equal to ut plus a half at squared. Alright, so we substitute. We have 49 being equal to u, which is 34.3 t minus a half times 9.8 t power 2. This here is the same as 49 being equal to 34.3 t minus 4.9 t squared. So if we are to rearrange this in a normal quadratic form, we have 4.9 t squared minus 34.3 t plus 49, giving us 0. Now, my dear viewer, I know you are in an advanced level, so you're going to solve the quadratic. Okay, you can use factorization, you can use the formula method to find the values of t. Now you will just confirm that those values are t is equal to 2 and t is equal to 5. Of course, this is seconds. Okay, now this shows that the particle is at a height of 49 meters after 2 seconds. That is for the first time. For the first time, it is after 2 seconds, and when it comes back for the second time, again at the height of 49 meters, this will have been after 5 seconds. Okay, so the time taken when it is above the height of 49 meters is getting 5 seconds minus 2 seconds, and that is 3 seconds. If we can add that one, time taken when the particle is above the height of 49 meters. So this is 49 meters, and above we are looking at this part here. So the time taken in this projection here is going to be 5 minus 2, and this gives us 3 seconds. So that's the time taken when the particle is above the height of 49 meters. Another example here, a brick is dropped from a scaffold board and hits the ground 3 seconds later. So we're going to have a scaffold here. This here is going to be our ground. So we have a brick dropped from this scaffold, and they're telling us that 3 seconds later the brick hits the ground. Now this scaffold is moving downwards. The acceleration here is going to be equal to positive g, right? And in part A, they need us to find the height there above the ground. I can call it h. And that will be our displacement. So displacement is equal to h. Alright, now since this brick was dropped, the initial velocity which it had was 0 meters per second. Since it was just dropped, it was dropped from rest. Okay, so now we need to find the height of the scaffold board. So using the displacement is equal to ut plus a half at squared. We need to modify this equation here so that we can be able to find the value of h in part A, which is the height of the scaffold. So we shall have to substitute h is equal to u, which is 0 times 3 plus half times acceleration, which is positive g, and has a value of 9.8. Okay. Then our time is 3 seconds. So when you simplify this here, this is 4.9 times 9. So h, which is the height of the scaffold, is 44.1 meters. So that's the height of the scaffold. Alright, in the second part, they need us to find the velocity with which this brick hits the ground. So we need to find the final velocity there. Now we've got the displacement, which is 44.1. We've got the acceleration, we've got the time. We can be able to go ahead and use the first equation, that v is equal to u plus at. We need to find v, so we have v being equal to initial velocity is 0 plus our acceleration is 9.8 times the time taken, which is 3 seconds. So when we work this out, 9.8 times 3, we get 29.4 meters per second. So this is the velocity with which the brick hits the ground. A boy throws a ball vertically upwards from a 7-meter high roof. So let's first have a sketch here. So this is our 7-meter high roof, and the boy is standing there. 7-meter high roof, and this is the ground. So this boy throws this ball vertically up. He throws it vertically up to reach a certain point, and then it will have to come back. So it will come back. When he misses it, it has to hit the ground. Part A, if after 2 seconds he catches the ball, so if he throws it up like this here, with the velocity which we do not know yet, but we can call it u meters per second, they are telling us that if after 2 seconds the boy catches the ball on its way down again, with what speed was it thrown? So they need us to find u. Alright, and this boy here, if we projected it from here, then he will have to catch it at this very point when it is moving down. And the time taken for this ball to move like this up to this point where he catches it is 2 seconds. Okay, now the displacement of this ball, if this ball has to move from this point and comes back to the very point, the displacement there is 0 meters. And this ball is going up, so the acceleration is against gravity. It's now negative g. We need to find u. So using the displacement is equal to ut plus half at squared. Our displacement is now 0 at the point where he catches the ball. At the point where he catches the ball, comma, the displacement is equal to 0 meters. So let's substitute in. We shall have 0 being equal to our u. We don't know it, but we know t, so we have 2u minus a half times g, which is now 9.8 times our time squared. We have this is 2 over 2. Our interest is u. So this is 0 being equal to u minus 19.6. Yeah. So this implies that 2u is equal to 19.6 and u alone is 9.8 meters per second. Part B. What is the velocity of the ball when he's catching it? Using v being equal to u plus at, we need the final velocity at this point. So we need the v. We know the initial velocity, and that's 9.8. Because the particle is being projected upwards, acceleration is negative g, so this is minus 9.8 times our time t, which is 2 seconds. So the final velocity is going to become negative 9.8 meters per second. So this negative shows that the ball is now moving in the opposite direction, right? And you can see that if the velocity at this point of projection is positive 9.8, then when it is moving in the opposite direction, the value is the same in magnitude, but then we have different directions because it is at the same level. We have part C also. If the boy fails to catch the ball, with what speed will it hit the ground? Now, if this ball has to hit the ground, the displacement of the ball is going to be negative 7 meters because whatever is up here cancels itself, and because we are moving in the opposite direction, so this becomes negative 7 meters. The acceleration due to gravity is still negative 9.8 meters per second squared because it was projected against gravity. The initial velocity u, we calculated it as 9.8 meters per second, and we are required to find the final velocity v. So using v squared being equal to u squared plus 2as, we are going to substitute in here. We need v, so we have v squared being equal to u, and u is 9.8 power 2 minus 2 times 9.8, which is the acceleration, times the displacement, which is also negative 7. V squared here, when you simplify, we are getting 233.24. So when you take the square root on both sides, v is going to be equal to 15.2722 meters per second. So from here we conclude and say the ball hits the ground with a velocity of 15.2722 meters per second. Now, my dear viewer, I would like to thank you so much for being part of EduMath up to this point. If you are new, please consider subscribing and hitting that notification bell. This has been the second part about motion under gravity. We have the third part coming, so stay around, and for now from us EduMath, we wish you the best and see you in the next video.